Page 77, we have some application problems. So we have Eileen driving from her house to the train station and then getting on a train away from her house. So let's draw a picture. House, train station, and New York, which I'm not going to attempt to draw an outline of New York, so there we go. Okay, it's 20 miles from her house to the train station. That's 20 miles. Apparently that's a really long train station. That's okay. Train's going at 55 miles per hour. That seems important. Before we even get started, I like to start with a picture, and then it says define the variables needed for this problem. Well, what might we want to know? We could want to know, we're told that this is 20 miles, so we don't have to figure that out. We're told that she's going on this train. The train goes at this speed. So maybe we want to know how far it is from the train station to New York. Maybe we want to know how far she's traveled after a certain number of hours. Maybe we want to know how many hours it takes to go a certain distance. So the distance between here and New York is a constant. I don't know what it is, but it's just some numbers, not a variable. So my variables could be the number of hours on the train and the number of miles from home. Number of miles is MI, otherwise it looks like meters. Okay, let's make these variables. Generally, time is an X variable, not always. But that's, if you have to make a guess on the dependent and independent variable, usually time is what we can kind of control in a sense, in terms of our measurements, and other things depend on the time. So I'm going to say X is the number of hours on the train, and Y is the distance from home. Okay, I want an equation to represent this. So Y equals mx plus b, but I have to figure out what's m. M is my slope, my rate of change. My rate, so 55 miles per hour. I'm going to write it out like this. Miles per hour, I can do that. That's a 1. Times x plus b. Now b is how far away I am when I start on the train. You can see from our picture, or from reading this again, it's 20 miles. There's my equation. Y is 55 miles over 1 hour times x plus 20 miles. If I know x, I can solve for y. If I know y, I can solve for x. 2 hours on the train, so that's number of hours, that's x. Let's plug it in. Y equals 55 miles over 1 hour times 2 hours. I'll put it over 1 so that it's a fraction. I can always do that. No units needed on the bottom. 20 miles. Okay, I'm going to multiply. Hours and hours cancel out. I'm left with 55 times 2, 110, over 1 times 1, which is 1. So 110 plus 120, both of those are, the only units left are miles. 110 miles plus 20 miles equals 130 miles. So she's 130 miles from her house. Okay, and D says after how many hours will she be 300 miles from her house? So D is saying, nope, forget C. Go back to the equation and figure out how many miles, or excuse me, how many hours it's going to take her to be about 300 miles away. Now we have to make some assumptions, right? We have to assume that New York is far enough away that it's at least 300 miles, because otherwise she's probably going to stop and get off when she gets to New York. So we're making some assumptions here, but that's the kind of assumption that you can feel free to write in, but you don't really need to worry about it too much. So I now have 300 miles. So 2 hours was my X. 300 miles is my Y. So 300 miles. And it says about, I'm going to use an approximately equal sign. 300 miles is approximately equal to, I'll use this equation, 55 miles over 1 hour times X plus 20 miles. Notice I'm keeping the units the whole way through. That way I know that things that I'm adding have the same units. If I'm trying to add 300 miles plus 5 hours, I'm not going to get anything that makes any sense. Okay, so 300 is about this times X plus 20. Opposite order of operations. So I'll start by doing what? Take a moment, think about it, pause if you need to. And let's subtract this 20 miles from both sides. So I get 280 miles. It's about 55 miles, 1 hour times X. Let's multiply the 1 hour over here. How do we want to do this? There are a lot of ways to do this. But yeah, why don't we do that? So we have 280 miles times 1 hour equals 55 miles times X. Now what? Well, I want X by itself. Let's divide by the thing that's multiplying it. Divide by 55 miles. Divide by 55 miles. Miles and miles cancel out. And I'm left with 280 over 55 hours equals X. So X equals 280 over 55 hours, which they said approximately, let's see, 55 goes into that about 5 times. 5 times 55 is 275. That's probably close enough because it said about. So again, about 5 hours. That about is an important thing to remember. And about 5 hours on the train. Okay. So number 2, we have Morgan buying a laptop, paying $45 per month for 24 months. So start by thinking about what the variables are. Some of these things are fixed. What do we need to know? Up here, we needed to know how far she was from home and how long she'd been on the train. What variables might we wonder? One has to do with time, maybe like how many months it's been. And what would the other one be? Pause and think about it if you need to. So we have the number months that have passed. And after so many months pass, we might want to know how much does she owe? Amount owed. So I said that time tended to be X because the amount that we owe depends on how much time it's been. So this is the dependent variable, X. This is the independent variable, Y. Write an equation to represent in this situation. Go ahead and take a moment to do that. Taking care to watch your signs. We want to know how much money she owes. So she starts out owing $1,080. She's going to owe a little bit less each month. Think about how you can arrange that. Once you have your equation, you can plug in to find out how much she owes after 8 months. So that's plugging in 8 for X or Y. Think about it. Yeah, plugging in 8 for X because X is our time in this case. And when does she owe 925? This one's a little tricky. Plug it in for Y, see what you get, and then decide if that's reasonable. Page 78. Whiteboard is still waking up this morning. It's not even morning. Okay, I always teach in the morning, so I just assume it's morning if I'm up here. Warren has $10 saved when he starts babysitting. He charges $12 an hour. We need to figure out our variables. What do we care about? We need to write the equation. We need to figure out when he has $400. And we need to figure out this question where we say, okay, if he's babysat for 26 hours and his uncle gives him $50, does he have enough? So we'll have to figure out how to adapt the equation that we have here to take into account this extra $50. And finally, Charlie is sketching pictures of their friends for the holidays. They spend 30 minutes gathering supplies. Sketches take them 4.5 hours each. So think about what variables you might need. What might you be interested in? Write your equation. And then if they work for 22 hours on this project, hopefully not all at once, how many can they get done? Then they decide to do 6 sketches. How long does it take? If you have questions on these, as always, work through them as best you can and bring them up in class. And that is the note tip. Thank you very much.